So in this question it is given that a uniform ring of mass m and radius r is placed directly above a uniform sphere of mass 8m and the same radius r. The center of ring is at a distance d, which is equal to root 3r from the center of sphere. The gravitational attraction between the sphere and the ring is. So Rm is to find out what about the value of force of attraction between a ring and a sphere. And in question it is given that the distance between the center of this ring and the center of this sphere is nothing but, which is given in question, that is root 3r. So this distance, let's say I'm taking it as x, which is given as nothing but root 3r. Now we know the equation for a gravitational field due to a ring at its axial line. So we know that if we are considering a point which is on the axial line, which is at a distance x from the center, so we can just revise that part. So you might be remembering that the gravitational field at a distance x from the center of a ring is equal to gm into x divided by r square plus x square raised to 3 by 2. Now in this question it is given that the value of x is equal to root 3 by r. So first we can find out what about the value of gravitational field. In question they are asking to find out the value of gravitational potential, but first we can find out what about the value of, in question they are asking to find out the value of gravitational force, not potential. But first we'll find out what about the value of gravitational field acting over here. From that we can find out the value of gravitational force. So gravitational field, the equation for a gravitational field is nothing but this. In this equation we can just put the value of x. X is nothing but a root 3 into r divided by r square plus, again x is root 3r, the square of that we can take it as nothing but 3r square raised to 3 divided by 2. So this term, the whole raised to 3 by 2. So this can be written as gm into root 3 into r divided by, we know that this r square plus 3r square is going to be nothing but 4r square. So this 4r square raised to 3 by 2. So this can be written as gm into root 3 into r divided by, now this can be written as 4r square raised to 1 by 2 the whole raised to 3. So raised to 1 by 2, it represents that nothing but 4r square raised to 1 by 2, it represents that nothing but a root of 4r square. So root of 4 is nothing but 2, root of r square is nothing but r. So this is basically nothing but 2r raised to 3. And we know that this 2r raised to 3, 2 raised to 3 is nothing but 8 into r raised to 3. So we can cancel 1r over here and 1r over here. So this is going to be g into m into root 3 divided by 8r square. So this is a value of gravitational field. Now in question they are asking to find out what about the value of force acting on a sphere of mass atom which is kept on the axial line. So Rm is to find out the value of force, but they are given the value of gravitational, or we find out the value of gravitational field. So whatever the things that we calculated in gravitation, we used to calculate the gravitational field, not the force. But in question, if they are asking to find out the value of force, then just write force is equal to mass into acceleration due to gravity. And we are keeping a sphere of mass 8m, so we can write m as 8m over here. And the value of g, we know that is equal to gm into root 3 divided by 8r square. So this 8 and this 8 is going to get cancelled. So I'll get the answer as g into m, we can take it as m square into root 3 divided by r square. So this is the value of final answer.